Let's start with a simple fact. Iran has major water problems, and the country has had some very ambitious ideas for solving them. For a time, Iran tried to negotiate with Turkmenistan to build a water network and buy some of the water from its neighbor's main river, the Amu Darya. It didn't work because all the countries in this region have water problems, and several neighboring states draw water from the Amu Darya. Furthermore, Afghanistan is currently building a large-scale canal that will further deplete the river. Nearby is another neighbor from whom they could try to buy water, Pakistan, through whose territory the Indus River flows. But for various reasons, that plan has also been abandoned. Perhaps it's time to abandon the idea of pumping water from somewhere. No, Tehran has a new idea: to start pumping millions of cubic meters of water from the Persian Gulf and distribute it throughout its territory via a 1,000-kilometer network. Yes, it seems incredible, but it's happening. And now we'll delve into all the intricacies of the country's lifeline project. This is the Amir Kabir Dam and the 202 million cubic meter reservoir it creates. It supplies water to Tehran, the capital of Iran, provides water for industry, irrigates 50,000 hectares of farmland, and is a source of water for many people. And here we have a picture from 2024 that must be terrifying for everyone living in an arid climate. The reservoir's water isn't being replenished in time. This is already a huge problem, but there's something bigger. The area surrounding the dam in Tehran isn't the driest in Iran. There are many more regions with rainfall problems in the country. For example, the central, southern, and southeastern parts of the country. There, an average of 0 to 250 millimeters of rain falls from the sky each year. Literally nothing to sustain any activity. So perhaps we should use groundwater? Well, this is what many places in Iran that extract water from the subsoil currently look like. So perhaps we should use groundwater. Well, this is what many places in Iran that extract water from the subsoil currently look like. You can see the funnel in front of you. Some parts of Tehran may soon be underground. Right now, the city is sinking about 25 centimeters a year. It's not happening uniformly, so it won't be a huge hole, but a capital city that has partially fallen underground isn't pleasant either. Why does this happen? The reason a sinkhole forms is because too much water is getting in. There's less water, it's not being replaced by anything, so a cavity forms and then everything collapses. In general, in an effort to get water from somewhere, the country is constantly being depleted of its groundwater. The Iranian Ministry of Energy estimates that the country loses 5 billion cubic meters of groundwater every year due to over-extraction. And in the last 5 decades, Iran has depleted nearly 70% of all its underground water reserves. In 2018, the country pumped 96 billion cubic meters of groundwater, which, although representing 51% of available renewable resources, is still far above the safe yield. This is all exacerbated by climate change, which is causing the country to suffer increasingly frequent droughts. The situation is perfectly illustrated in this map. The more saturated the color, the more severe the water problems in a given region. Most of Iran is experiencing a major water crisis. What is most striking is that all of this has done absolutely nothing to curb population growth. In 1960, the population was just over 21 million. Now, in 2025, it has grown to 90 million, more than 4 times. We believe everyone understands what population growth means when the country is already facing a water crisis. There are more people who need drinking water, more industries, and more agriculture that creates goods for the population. This also increases the demand for resources. According to the World Resources Institute, Iran is the most water-scarce country in the world. Between 80% and 100% of all renewable resources are extracted there each year. In other words, all available water is used for agriculture, industry, and domestic needs. This leaves very few reserves for periods of drought or rainfall variability. It's a deplorable situation that the Iranian government is undoubtedly considering, wondering where to find water. The first conclusion is that dams are needed. By the middle of the last decade, more than 640 dams had been built in Iran, 523 of which are considered large-scale facilities. Yes, water is being stored. The total reservoir capacity of all the dams exceeds 50 billion cubic meters. That is to say, a significant amount of water has been added to the supply chain, which can be used for various purposes: irrigation, industry, and agriculture. However, the end result is that the amount of water in rivers is decreasing, which has led to the drying up of some lakes. For example, let's look at Lake Urmia. This is a photo from 1984, when the lake's surface area reached 6,000 square kilometers. And this is from 2023. What was once the sixth largest salt lake on Earth has shrunk to less than 10% of its original size. You might say that the lake is naturally salty, so you can't drink from it. Yes, but at this rate, it will become a large salt marsh, and that will exacerbate the climate problem. Iran has realized that in the current situation, another solution must be found: other sources of water for the population, industry, and agriculture. On the map, there aren't many places where potable water can be obtained, so we look to the Persian Gulf. There is a huge amount of water there waiting to be channeled inland. And then there's the Gulf of Oman, which is also a prime candidate to serve Iran. The only problem is that both water sources are unsuitable for normal use because they contain an enormous amount of salt. For example, the water in the Persian Gulf has an average salinity of about 40 to 41 grams per kilogram of water. In the Gulf of Oman, the situation is more or less the same. At the same time, the average salt content in the oceans of our planet does not exceed 35 grams per kilogram of water. Generally, salt water is considered a problem, but not in the case of Iran. This country only has to look to the opposite shore and see how Saudi Arabia is actively engaged in desalination to supply its territory with drinking water. This is the scheme: take water from the Gulfs, desalinate it, and then send it through artificial waterways to the appropriate locations within the country. Thus, the first route begins in the Strait of Hormuz, where the Persian Gulf joins the Gulf of Oman. The water is extracted, desalinated, and then travels through a pipeline across Hormozgan province to Kerman and Yaz. The total length of the pipeline is 826 kilometers, and the annual capacity is 180 million cubic meters of desalinated water. Of this amount, 50 million cubic meters are taken to Hormozgan province, where the water is distributed to all who need it. But the remaining 130 million cubic meters, which go to Kerman and Yaz, are allocated to industry without exception. There are as many as 3 industrial complexes in the provinces: Golgajar, Sarkezme Koper, and Chador Malo. Their importance cannot be overstated, as Sarkezme Koper alone houses several smelters and one of the world's largest mines. For this reason, abundant water is essential, and it is dangerous to continue depriving the population and agriculture of it because, if the shortage worsens, unrest will erupt. So in this case, reducing the strain on existing water sources and allowing desalinated water from the bays to come into production is the most appropriate solution. Currently, this part of the enormous network is already operational, so its benefits are being reaped by everyone, including Iran itself, which spent some $50 million on its construction. Even so, 180 million cubic meters per year is not enough to supply drinking water to 2 struggling provinces. The Iranians, of course, have considered this, so they have opened a second water pipeline parallel to the first. However, it is capable of transporting 200 million cubic meters of water per year. Another line is to be built that crosses the 3 provinces through which the first one ran, but only as far as Isfahan. There is also a third route, which starts in the Gulf of Oman, passes through the provinces we already know, and then reaches the province of Isfahan, which is new to the system. Today we've already discussed Iran's water problems, but they're even more pronounced here, as 33% of the province's surface area is desert. Furthermore, 10% of the country's deserts are located here, so water is a major issue, and a desalinated water pipeline reaching this area is the most sensible solution. It's also one of the most expensive. The investment in this pipeline is $2.7 billion. However, even here, everything is quite reasonable. Iran had to, and still has to, lay the pipeline through deserts, mountains up to 1,500 meters high, and low-lying areas, which undoubtedly increases the construction cost. Moreover, the solution will certainly be profitable because most of the water will be used for industrial purposes. Once completed, the pipeline in its 2 sections will be able to transport approximately 600 million cubic meters of desalinated water to a province with critical needs. At the moment, it may seem that Iran isn't truly concerned about its population, which suffers from water scarcity. Industry is more important. However, another perspective aims to dispel this notion. Eastern Iran is the most underdeveloped part of the country, comprising provinces such as Sistan and Baluchistan, South Khorasan, and Razabi Khorasan. Sistan and Baluchistan would seem to have the greatest potential for industrial development because it borders Pakistan and Afghanistan, meaning that it could produce goods and then sell them to its neighbors. But things are very bad here. There's practically no industry, and every new business is a miracle. Agriculture is developed here, but it too is problematic for the same reason that new businesses are scarce, a severe water shortage. It does rain here, but on average only 70 to 130 millimeters per year, and sometimes the rain comes in torrents, bringing only destruction. But is it possible to capture the water that falls from the sky? Unlikely, because in summer, temperatures here can reach 50 degrees, which requires evaporation of everything that has fallen from the sky. Do you know what's very common here? Camel breeding, for which the most suitable conditions are heat and dryness, and that's another indicator that water is scarce here. Located to the north, South Khorasan is also a problematic area. Here, the average annual rainfall is 134 millimeters. 22.7% of the surface is desert, and another 63.3% is desert grassland. That said, industry is much more developed here. However, due to the lack of a key drinking water resource, development is very slow because many people simply migrate to where there is more water. The northernmost of the eastern regions is Khorasan Razavi. Here, there are fewer desert areas, and the climate is suitable for agriculture. The province ranks first in the production of cherries, turmeric, melons, saffron, and plums, and produces many other agricultural products. But in recent times, problems have multiplied due to climate change and the active extraction of groundwater. It is becoming depleted, and rainfall is decreasing. As a result, Khorasan Razavi could soon go from being the country's largest agricultural producer to a drought-stricken area from which most of the population will flee. But let's not get too downcast, because we understand that Iran has opted to create artificial rivers to channel water to the most arid regions. Specifically, one of the pipelines under construction will cross these same eastern provinces. The water is drawn from the Persian Gulf and then distributed 1,342 kilometers through all the needy provinces we just mentioned: Sistan and Baluchistan, South Khorasan, and Razavi Khorasan. The previous pipelines cannot be compared in any way to the new one in terms of capacity because there was no need to supply water to such a vast number of areas. The pipeline that crosses the 3 provinces has a capacity of 2.4 billion cubic meters of water. Therefore, the pipeline will be Iran's largest desalination and desalinated water transport project, requiring an incredible expenditure of up to $3.2 billion. As of 2023, 12% of the entire route had been completed, and the completion of all the works is not expected for a long time. One of the reasons is that it is very complex. Planners, engineers, and builders have to contend with challenging terrain: deserts, mountains, and hills. In short, everything that delays construction and makes it expensive. Adding to the complexity of construction is the opinion of numerous experts who ask, could something be done about evaporation instead of laying enormous pipelines across the country? We couldn't agree more. Look, the country receives approximately 400 billion cubic meters of rainfall annually. Do you know how much of that evaporates? 70%. Only 30% is available for consumption. This is primarily due, of course, to the lack of adequate infrastructure to capture Iran's seasonal rainfall, which strikes the country suddenly at certain times. Imagine, with a small step, reducing annual evaporation by just 1% could meet the water needs of the country's smaller industries. To avoid water problems, it is, of course, necessary to invest in new infrastructure suited to the country's conditions. In general, experts say that the main thing is to develop a water management policy. For example, many critics of the desalination and transport project argue that the volume of water consumed by the country's industrial sector is very small. And in the Central Plateau, where the main remnants of the project are directed, it is 1 billion cubic meters. Instead of investing billions of dollars in desalinating salt water and then transporting it, one could simply divert some of the available water consumption from agriculture to industry. Furthermore, it must be considered that transporting water from the sea increases the consumption of fossil fuels and atmospheric carbon emissions, which is harmful to the environment. But a country that already contributes around 1.8% to global greenhouse gas emissions, ranking 8th in the world, is unlikely to realize this. And it's also one of several countries that hasn't ratified the Paris Climate Agreement. But the emphasis on desalination continues, so we can be confident. The construction of this pipeline, as well as the rest of the massive desalinated water supply project, will definitely be completed. Do you know what else is coming to Iran's rescue in the fight against the never-ending water crisis? The unexpected. 15% of the country's total water demand is met by something invented some 2,500 years ago. It's called kanad, a water supply system invented in ancient Iran. It's used to transport drinking water from an aquifer or well to the surface. Understandably, in ancient times, there was no modern equipment to locate groundwater, nor devices to pump the water. So the ancients devised an ingenious system. There are accumulations of water at the foot of mountains. The water itself flows from the top down, so no additional device is needed to set it in motion. There are accumulations of water at the foot of the mountains. The water itself flows from top to bottom, so no additional device is needed to set it in motion. So people made the water from the higher elevations simply flow down to where it would be used. Thus, the canads were born. The system consists of a series of vertical shafts, similar to wells, connected by a smooth tunnel. The water flows through it without any additional stimulus. Everyone is happy. There might actually be doubts about the usefulness of the system in the complex Iranian environment. The systems are old, cumbersome, and building something like this isn't as simple as laying a pipe and installing a pump. But the canads saved the day. The thing is, the old water tunnel is located entirely underground, so the water is resistant to evaporation in absolutely any climate, even the harsh Iranian climate. There's a reason the system was invented here. As for contamination, water flowing underground is generally more difficult to pollute because it needs to be accessed. Furthermore, the system is resistant to floods and earthquakes, as well as other catastrophes that characterize the modern world, including man-made disasters and military destruction. And this is a yakul, simply put, a refrigerator. More specifically, a complex ancient system with which Iranians can probably still store ice in the desert during the summer. So, what does an ancient water transport system have to do with it? The ice is placed in a space insulated by thick walls that retain the cold well. At the bottom, there is a connection to the kanad, from which cold air flows, blowing the ice inside the yakul and expelling the hot air through the ventilation system. The frozen resource is stored and does not melt, even in the high-temperature desert conditions. In short, escaping water scarcity can be done the old-fashioned way. However, modern solutions like desalination cannot be ignored. Only an integrated approach will help solve the water catastrophe.